Okay, ELE 115ers. Going to do a little bit more here with, let's see if we can get this adjusted properly. I guess not. So, I have this thing here, which is a motor. I think this one might have come from a cassette tape player, but I'm not sure. Anyway, it's a motor, and this is a DC motor, in that it has some contacts in it that make it turn one way in one polarity and the other way in another, and it's got a little gear on there. And so if I connect this to my homemade power supply here, which at one time was a Dwell tachometer, for those interested in automotive type stuff. This goes 0 to 12 volts, so I'm running 0 to plus 12 over here, 0 to minus 12 over here. But this is about halfway, so it's like 6 volts. So if I put this on here like this, I don't know if you can tell, but that motor is spinning there, okay? And one way we can probably enhance that is to take a magic marker, and we'll put a mark on there. And this motor's, it's kind of heavy. Oh, sorry. The motor's kind of heavy. It's got magnets in it with wires wound on things, and I suppose it's not very convincing that it's all covered with metal, but here goes. So let me get a hold of this thing. Let's put power to it, and I will slow this down if I can by putting less. You can see that something's moving on there. Now you can see the black line going around, and more voltage applied, more current flows, the motor goes. And if I were to switch the polarity, which I could do right here, and plug it in this way, because it's a DC motor, I mean there's all kinds of motors, but because it's a DC motor, it'll turn the other way. See how it's going around now? And if I go back, and that's great. This is electricity in with motion out, and that's a motor. Okay, whatever kind of motion it is. The word motor is actually more general than we think it is. And here it is spinning, the other way. So polarity matters in a DC motor. Okay. But now let's look at the other thing here. I'm going to kill the power supply, and as the power supply discharges there, that eventually shuts off. Now let's hook it up to this oscilloscope. Now I have an oscilloscope probe here. Maybe I can even move this over, and alright, looks like it auto-focused, but just in case we'll auto-focus it again. And here's my motor, and I have it hooked up to this to the channel 1. It's actually this channel over here. And if I if I do nothing here, let's see, the mode is auto, I just get a flat trace across there because nothing comes out. But if I give it a good spin, you can see that I create these pulses, and these pulses, let's see, it's not really in focus, but if you look here, it's 2 volts per centimeter. So as I spin this thing, I'm getting 2, 4, 6, 8 volts, maybe even a little more sometimes going over the top. So you can see that this could be an effective generator. And if again, it's a DC motor, so if I spin it the other way, the pulses I get out are negative. All right. So that's just an example of a of generating that, you know, how inductance works. If I put energy into the inductance in the presence of a magnet, I will get movement. In this case, rotary movement in a motor, or circular motion from a motor. If I spin the motor, then the wires in the motor are moving with respect to the magnetic field, and I get my here. Let's see me do that just to be a little more convincing there. So there are some pulses caused by spinning the motor, and if I spin it the other way, you get the negative pulses. All right, and that's all I wanted to show with this particular video. Okie doke. Thank you very much. More to follow.